The mystery of floating ships, science or magic. Have you ever wondered about something that seems almost magical? If you drop a tiny needle into water, it sinks instantly. But a gigantic ship, weighing thousands, even hundreds of thousands of tons, floats effortlessly across oceans. How is that possible? Is it magic? Is it engineering genius? Or is it pure science working behind the scenes? Today, we are going to uncover one of the most fascinating secrets of physics, the mystery behind why ships float. And trust me, by the end of this video, you'll never look at the ocean the same way again. A simple observation that sparks a big question. Let's start with something simple. Take a small steel needle and place it in water. It sinks. Now imagine a massive oil tanker, made primarily of steel, carrying millions of liters of oil. It floats. How can something small and light sink, while something enormous and unbelievably heavy stays afloat? At first glance, it seems to break all logic. But here's the truth. Nature never breaks its own rules. There is a precise scientific explanation behind this phenomenon, and that explanation begins more than 2,000 years ago. The story of a genius, Archimedes, and the Eureka moment. In ancient Greece, there lived a brilliant mathematician and scientist named Archimedes. Legend says that one day, while taking a bath, he noticed something curious. As he stepped into the tub, water spilled over the edges. That simple observation led him to one of the most important discoveries in physics. He realized that when an object is placed in water, it displaces or pushes aside a certain amount of water. And suddenly, he understood something revolutionary. He jumped out of the bath and ran through the streets shouting, "Eureka!" which means, "I have found it." What had he found? He had discovered the principle of buoyancy. Understanding buoyancy, the force that makes ships float. Buoyancy is the upward force that a fluid, like water, exerts on an object placed inside it. According to Archimedes' principle, an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. Let's break that down in simple terms. When you place something in water, it pushes water out of the way. The water pushes back, and that push, that upward force, is what we call buoyancy. If the buoyant force is greater than the weight of the object, it floats. If the object's weight is greater than the buoyant force, it sinks. That's it. No magic. Just physics. Why the needle sinks. Now let's return to our needle. A steel needle is small, compact, and dense. Density is the amount of mass packed into a certain volume. Steel has a high density, much higher than water. When the needle is placed in water, it displaces only a tiny amount of water because it occupies very little space. That means the buoyant force pushing upward is very small. But the needle's weight is still greater than that upward force. So it sinks. Simple. Why a ship floats, even though it's made of steel? Now here's where things get interesting. Ships are also made mostly of steel. And steel sinks, right? So why doesn't a ship sink? The answer lies in design. Ships are not solid blocks of steel. They are hollow. Their structure includes large empty spaces filled with air. This dramatically increases the ship's volume without increasing its weight proportionally. Remember Archimedes' principle? The buoyant force depends on how much water is displaced. A ship's wide and hollow design allows it to displace a huge amount of water. That means the upward buoyant force becomes enormous. As long as the buoyant force equals or exceeds the ship's total weight, including cargo, fuel, and passengers, the ship floats. Let's use a real example. Imagine a massive oil tanker carrying 2 million liters of oil. That's 2 million liters. Incredible, right? Despite this enormous load, the ship remains afloat. Why? Because the total weight of the ship and its cargo is balanced by the weight of the water it displaces. If the ship displaces water weighing 100,000 tons, and the ship itself weighs 100,000 tons, it will float perfectly. It sinks only until the displaced water's weight equals its own weight. Nature always seeks balance. Density, the hidden key. There's another crucial concept here, average density. Even though steel is denser than water, a ship is not just steel. It contains air spaces. When you calculate the ship's overall average density, including the hollow areas, it becomes lower than the density of water. And here's the golden rule. If an object's average density is less than the density of the fluid, it floats. If it's greater, it sinks. That's why a massive cruise ship floats. And a tiny marble sinks. Density, the hidden key. There's another crucial concept here, average density. Even though steel is denser than water, a ship is not just steel. It contains air spaces. When you calculate the ship's overall average density, including the hollow areas, it becomes lower than the density of water. And here's the golden rule. If an object's average density is less than the density of the fluid, it floats. If it's greater, it sinks. That's why a massive cruise ship floats. And a tiny marble sinks. Water pressure and stability. When a ship floats, it is not just sitting still on top of the water. Water pressure acts on it from all directions. Pressure increases with depth. The bottom of the ship experiences greater pressure than the top. This pressure difference contributes to stability. Engineers carefully design ships to maintain balance. The center of gravity must align properly with the center of buoyancy. If the center of gravity is too high, the ship can become unstable. That's why heavy cargo is stored low inside the hull. That's why ballast tanks exist, to adjust weight distribution. It's a masterpiece of engineering precision. The role of ship design. Modern ships are designed using advanced computer simulations. Engineers calculate weight distribution, cargo load limits, water displacement capacity, stability angles, wave impact forces. The wide, flat-bottomed hull allows maximum displacement. The curved shape reduces drag. Every angle, every curve, every material is carefully selected. A floating ship is not luck. It is the result of deep physics combined with brilliant engineering. Wooden boats, the same principle. Let's simplify again. Think about a small wooden boat. Wood is less dense than water, so it floats naturally. But even if you carve out a large piece of wood into a hollow canoe, it becomes even more buoyant. Why? Because you increase volume while reducing average density. Same principle, different scale. From a tiny fishing boat to a gigantic aircraft carrier, they all obey the same law discovered thousands of years ago. What happens if a ship is overloaded? Now let's ask an important question. If buoyancy depends on displacement, what happens when a ship carries too much weight? As more weight is added, the ship sinks deeper into the water. It displaces more water. Eventually, if it cannot displace enough water to balance the weight, it sinks. That's why ships have load lines, often called the plimsoll line. This marking shows the maximum safe loading level. Exceed it, and you risk disaster. Physics does not forgive mistakes. Submarines, floating and sinking on purpose. Here's another fascinating example. Submarines can float or sink intentionally. How? They control buoyancy using ballast tanks. When tanks fill with water, the submarine becomes heavier and sinks. When water is pumped out and replaced with air, it becomes lighter and rises. The same principle, controlled precisely. This is Archimedes' principle in action, mastered and engineered. The ocean is not always calm. Floating is one thing. Surviving storms is another. Ships must handle waves, wind, and currents. Engineers calculate dynamic forces. They test stability under extreme conditions. The ship's hull shape helps it cut through waves. Modern materials provide strength without excessive weight. Floating is just the beginning. Sailing safely is the real challenge. From ancient boats to modern giants. Thousands of years ago, humans built simple wooden rafts. They didn't know the mathematics of buoyancy, but they understood the practical result. Over time, knowledge evolved. Today we build container ships longer than skyscrapers are tall, cruise ships that are floating cities, aircraft carriers that function as mobile military bases. Yet every single one depends on the same scientific principle. Archimedes would be proud. Why this is not magic? When you see a massive ship floating, it may look magical. But magic is simply science we do not yet understand. Now you understand. Floating is not about weight alone. It is about density. It is about displaced water. It is about balance. It is about physics working perfectly. The bigger lesson, the story of floating ships teaches us something deeper. Sometimes, what seems impossible is simply misunderstood. A needle sinks. A ship floats. It feels contradictory. But once we understand the principle, the mystery disappears. Science turns confusion into clarity. That is the true power of knowledge. The future of ship technology. Modern shipbuilding continues to evolve. Engineers are designing more fuel-efficient hull shapes, eco-friendly propulsion systems, smart stability monitoring systems, autonomous ships guided by artificial intelligence. But even with all this technology, the foundation remains the same. Buoyancy, displacement, density, balance, ancient science, modern innovation, perfect harmony. Final thoughts. So, the next time you stand by the sea and see a giant ship crossing the horizon, remember this. It is not magic. It is not a miracle. It is a beautiful demonstration of physics in action. A tiny upward force multiplied across millions of liters of displaced water, lifting thousands of tons effortlessly. That is the elegance of nature. That is the brilliance of engineering. And that is the mystery of floating ships, solved by science. If you found this explanation fascinating, imagine how many other mysteries around us are simply waiting to be understood. Because in the world of science, the more we learn, the more amazing reality becomes. If you enjoyed this deep dive into physics and engineering, don't forget to subscribe to our channel. Like the video, share it with someone who loves science, and stay curious, because curiosity is where every great discovery begins.